In this video, I talk about dynamic assignment. This is the first one in the series. We'll make more, but in this one, I think it's important to just discuss the very basics, what it is, how it works, and things like that. I keep it very simple, don't go into the details. So dynamic assignment is basically a module in Vissim which allows you to model traffic using matrices or trip chain files. And what it does, it basically finds the routing itself, so you don't need to use like static routing and tell every vehicle where to go. And it also allows for route choices and route search. So you can basically, this is for bigger networks mainly, or simple networks if you don't want to bother with static routing. It requires a different way to build a model um, most of the cases. So you need to deal with like lane changes, and especially if you have big intersections, big junctions, you need to deal with um, vehicles and how they get through the network and things like that a bit differently. But I will try to show examples in the upcoming videos for that one. But in this one, let's keep things simple. So what I did, I just built a very small network with a lot of route choices in it. And so when you want to use dynamic assignment, you need to go to traffic and dynamic assignment. Basically, all of the stuff can be found here. Let's start with the parameters. So when you want to use dynamic assignment, you need to go to the files and you need to tick on matrices. And here you need to load in your matrix, assuming that you don't use strip chain files. So you either use strip chain files or matrices or both. You can combine the two. Strip chain files needs to be loaded via an external FKT file, basically a text file, and you change the extension. And in the new Vissim versions, matrices are stored inside the Vissim model file and not an external file. In the old Vissim versions, they were stored in a separate file. So what you need to do is you just need to basically go to dynamic assignment and matrices, and let's create a demand here. You click add, and it brings up the matrix editor. You can see the zones here. So there are two zones here already. I created two zones. The way to do it is dynamic assignment zones, and you just create 1 and 2. There is already one zone by default, so you just click it and then the third one if needed, or you delete it. So I just add um, a demand, let's say 200 vehicles from zone 1 to zone 2. So the rows is basically the out and the columns are the in to that zone. So from 1 to 2. And if I want to place, so basically in a dynamic assignment, all traffic is generated and attracted through car parks or parking lots. So let me place a parking lot and show how it goes. So you place it, let's say here, and you click zone connector. Of course, you can use like real parking space, obstruct, and so on, and you can assign a zone. But these are for trip chain files, more applicable for trip chain files. So basically, you just need to use a zone connector where vehicles will just appear in that car park and will disappear in another car park. So I set it to zone 1. And as you can see, there is a tab here called dynamic assignment. Yeah. And when it is a generator zone, so where traffic appears in it, it has to have a relative flow greater than 0. And default desired speed, you can set it to 30. So if you remember, when you create vehicle composition, here there's a desired speed. This is only used for when you use it with vehicle input. when you use in a matrix that vehicle composition, that will be ignored. And the car parks or parking lots settings is used. Okay, you can add the name if you want. Let me okay that, and I add an exit zone. The length can be anything, so it can be like this big or anything, it doesn't matter. You can just double click on it. So again, zone connector, and as you can see, it also changes the way it looks. If you have a multi-lane road or a link, it will extend it and fill out the whole one. Okay, zone connector, zone 2, and here relative flow must be 0 if it is an exit one, or otherwise you will get an error that it can't find a route from this car park or this zone. And again, the speed is not applicable in this case since it is only used for attracting traffic. Okay. When you use dynamic assignment, nodes comes into play, or nodes come into play. You always need to have a car park between nodes. And again, here this use for dynamic assignment must be ticked in. Evaluation, you can leave it. It will be included and considered for node evaluation. But use for dynamic assignment must be ticked in. And again, it doesn't matter if the next node is here or up like here, a big one. And again, the shape doesn't matter. So it can be like this, or it doesn't matter if it's tiny. And it can be like this because Vissim uses the wireframe, so that center line only. So if you want, you can make it like as tiny as this. But I don't really like it that way, and I hate the wireframe mode as well. So it's gonna be like that. You need to do the same here. Okay, now what we do is we go to the parameters. You make sure that it is selected. Right click here, add, and add the matrix here, 1. Vehicle composition and default. I already have that by default. So let me okay that. When you go to this matrix editor here, you can see there is a from time and a to time. The vehicle demand here, the 200, it is not in vehicle per hour as it would be in vehicle inputs. Here what you add, that is for the period. So if I have 1 hour here, then it is 200 vehicle per hour. If it is 30 minutes, my metrics, then it's 200 vehicles in 30 minutes. So it's 400 per hour. So just something to keep in mind. It can cause you issues. I'm going to model only a 15 minutes in this case. I make sure that the setup is also the period is 900. And when you run dynamic assignment, you need to make sure when you run it for convergence, so when you basically build up the routes, that the non-random seed increment is 0. I will talk about that in another video when you understand better what a dynamic assignment is or how it works in detail. Number of runs. So when you run dynamic assignment, it is important to know that one run is not a run, basically, because when you run your dynamic assignment, there is no path files here in the folder. So that means it doesn't really know what's going on. It hasn't found paths yet and coasts. When we go back to the parameters, if you come here down, there is a coast file and a path file. If you want, you can select a different one. If you want, you can select a different one here. and here. But you can just use whatever it is, or if it's empty and there is a question mark, you can just use it and it will create one matching your model name. And create archive files. Um, After each run, it will save a path file and a cost file, because what it does, it basically after every run, it saves the path. It appends that path into the path file. So the more run you have, the more paths it can have, basically. And the cost is, there is also a cost associated to that path information. You can store costs and you can store paths and volumes. So you can just tick if you want to store these, and you can select what if you want to store them specifically for certain vehicle types. I would just keep these here by default, and check edges. Check edges. You can just keep that. That will basically that will do an extra check before when you want to run your model. If you make any changes to the network and that the new network doesn't match up with the paths you have in the path file, you will get an error. So you will need to create basically a new one. So if you run it to converge, um, you need to run it again. So what does it mean to converge, or how a dynamic assignment is run? So if there are alternative route choices in the model, you basically need to run it enough times for your model to converge. When it converges, what that means is there are all kinds of in here uh, conditions it can meet. And the required number of consecutive runs basically depends on your country or your authority and the guidelines you are working with. There are different requirements what you need to use if you want to travel time on paths. But basically, in simple terms, it means that vehicles found their best routes. So everyone is driving on their best one, where vehicles incur the least costs and they the best for them. And that can be set using all these settings basically um, here and set up in the choice and costs and so on. But I think by default, you just go with all the default settings. You can just set up maybe like this, just tick on travel time on paths and click OK. And it will basically ask you, if you run it enough times, it will ask you, you want to carry on doing all the leftover runs, what you set here. If you have like 100 run and it is converges on the 20th, then you will be asked if you want to stop or you want to keep running it. Yeah. And you can also save the convergence here into a file, that information, and you can also have a look how it works. If you are interested, we can have a look at that data as well in the future. Okay, so let me then run the model to show what actually it does. So let's just go back to the parameters, have a look. I have the model set up the metrics in it. I have the cost and path file, and that's it. And all the other stuff. So search new paths, search alternative paths. I have these turned on. I recommend you to do the same, and stochastic assignment. And you can also, with these logit function inputs and these pre-selection conditions, you can change the assignment. But let's just keep everything simple here and just make sure you tick these when you run it to converge. So if I start running it, you will notice that basically all vehicle use the shortest route in the first run. And then when it's over, it automatically starts the next run. Then they will use a different route. So basically they are exploring your network. Let me speed it up a bit. Then they found another one. Then they found another one. And they basically, let me just open up the files here. So as you can see, since I selected create archives, I can take the wake file, the WEG. This has the paths here. And what you can see is there is one path there. There are the edge network. I'm going to show you what that is. This is the second. Let me open the third. As you can see, there are two paths. And the current one is always the most recent one. And if I open that, you see there are a lot more paths. And basically, as I run the model, it keeps finding new and new paths until it has all possible routes or paths, sorry. Let me put it faster. And what will happen, as you can see, now they try to balance out the traffic. And if you run it enough times, it will find the best one according to the current settings. And you will buzzed if you want to keep running it or not. And this is the one. All convergence conditions are met. Stop the multi-run. You can stop it, continue to the end. So I'm just going to stop it. What you saw there is an edge network. So if you go to edges, static assignment edges, you can see the edge network here. Edges are always between basically the edges of nodes. Since I don't have a node here in the middle, one edge will be basically represent the whole path from one to another, the generation to the origin to the destination. So all these are my edges, and you can see there are little edges between the edges of the nodes. And when you go to the path, you see all edges here, like edge number from node to node and link sequence. And here it shows the paths, path number from parking lot to parking lot, edge sequence. So if I take path number 2, the edge sequence here, I think, is this one. So 1, 12, 9, 14, 10. So 1, 9, 1, 12, 9, sorry, 1. So this is the first 1, 12, 9, and then probably this comes 14 and 10. So as you can see, this is the way it works. And when you have complicated junctions, you can always close certain edges by the closed. And then it will be ignored and basically banned for anyone to use it. And this will be in place even in the first run. So when you run and there is no path file and you run your model, it will also always pick up the shortest path. But if there is a closed edge, it won't, that path can't have a closed edge. So the shortest path without a closed edge on it. But for example, if you go to vehicle routes, closure, you can close it like that. And then you can just drag it like this. So it's basically the same edge, but this closure would be not considered for dynamic assignment in the first run when you don't have a path. So vehicle in the first run will find this as a path and they will drive on it, and then it will be ignored from the second. run, and so on. I know it's a lot. um, I will keep making videos in this dynamic assignment, and that will help you to pick up. So make sure you stay tuned. So subscribing would help, obviously, and also like, please, the video. Um, yeah, and let me know your comments, questions, and any ideas in the comment section below. Cheers.